Hi guys, Sajjad Hussain again. I stopped this video after completing the geometry of this structure. Now let us start to apply the loads on this structure. First, I applied the dead load or the load on the roof. Let me change the units, meter and kilonewton. Okay. So what I did, I first applied the dead load of the roof because this structure is open from all sides. It is just a simple warehouse. It is open from all other sides. Just there is a roof. So the roof consists of panels, sheet panels. The weight of the sheet panel has been considered and the bracings etc. all considered. The load comes out to be around 1 kilonewton per linear meter in the mid beams and half a kilonewton on the edges. Of course, self weight is applied. Similarly, the load on the live load on the roof is taken as 20 pound per square foot as per the standard, and similarly I calculated the area and multiplied by this load and ended up with such a small load on the beams. Now I want to apply the seismic load. First I have to define the seismic parameters. As I mentioned in my calculation report that this building is supposed to be in Miami, where SS value is 0.065 and S1 value is 0.024. Based on that, I did all the calculation and it is established that the seismic design category assigned to this building is SDCA. And the value of CS comes out to be 0.01. So all this calculation is done here just to establish the value of CS. So here finally the value of CS is 0.01 and seismic design category is SDCA. That means we need not to do any special consideration in our design. It's a very simple structure. It will be designed according to the codes. No special consideration. So all these calculation is done separately. I also calculated the time period in both the direction. Here it is only in north-south direction. I do calculated the time period for east-west direction. All these parameters I will input to the seismic load generator of STAAD. So let us add the code selected is IBC 2006 or 2009. We will provide the values of SS and S1. SS, if you remember, the value of SS is 0.065. The value of S1 is 0.024. The time period is 4 seconds. This is the longest time period or maximum time period. Importance factor is 1. The response factor here, let it be 3 and 4. Safety class is site class is 4. FA is 1.6. FV is 2.4. The time period in X direction is 0.314 and time period in Z direction is 0.529. Add self weight, of course 1, so I added these values over here, and now I will add the load cases. So let me add a load case number 1. This will be seismic. Add. Okay. This is seismic load in X direction. Factor is 1. Okay. And of course I have to add load case number 2, seismic. That should be in Z direction. Let me add this one also. So here load is seismic, Z direction, factor 1 added. Now let me put the load cases in proper order. Let me add it manually. Go at the end. So load case number 1 and 2, it will go on the top. Let me paste it over here. So now load case number 1, 2, 3 and 4, they are defined. Now I have to add load case for the wind. Load case number 5 is the wind load. Wind in X. Load case number 6, wind, that will be wind in Z direction. That's that. Now instead of using the wind load generator, what I did, I have calculated manually the wind load on this structure. Let me show you the wind load generator, wind load calculated here. As per the given parameter, the wind speed is 145 miles per hour. Occupancy category 2. Importance factor 1. Exposure is B. And KD, KZ, etc. all these values are there. So accordingly I calculated QZ. QZ comes out to be 2.189 kilonewton per meter square. So as per section 6.5.8, for open structures, the value of G and the value of C for various members are given. So based on that, what I did, I calculated the force on the column. Here the force on the column, here force on the beam, and here is the force in the bracing. Then I calculated force on the roof, that is the upward force on the roof beam. So all these values are calculated over here. So let us apply one by one. So load on the column is 1.303 kilonewton per meter. Let us add member load and of course uniform force. This is in positive X direction. meter and kilonewton. So I have to add member force, uniform force, which is positive x 1.303 in x direction. Let me add it, and this will be acting on all the beams which are parallel to y-axis. So these are the forces. Let's increase the distributed force. Oh. Yes. So this will show the forces in x direction. Similarly, I have to select forces on beam. The forces on beam is 0.67 kilonewton per meter. So let us add member x 0.67, add, and here I have to select beams which are parallel to z direction. So let us apply. Load on the bracing is 0.335. So let me apply, add member force 0.335 in x direction, and I have to apply on all the bracings. Let me select the bracings. Okay. So let me select the bracings. Okay, so here assign to the selected beams. Right, so this is all wind forces acting on the members. Now for the roof, as I calculated, the roof beam will have a force of 6.38 kilonewton per meter. So let me add this force also. Add member force 6.38, and it is acting in y direction with a positive sign. Let us add, and these will be acting on all these members. Sorry, it is better I should cut this section. ZX 8.9 to say 13. Okay, so let me select like these. Okay, assign to selected beam. Yes. So now these forces are acting like this. This is wind in x direction. Similarly, we can apply wind in Z direction. Let's suppose the same thing is applied in Z direction also. Add. We can do one more quick thing. Let's use our editor. Let's go back over here. Copy, paste. I don't need this foot-pound over there. I can delete this unit command, and instead of GX it should be GZ, 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 1, 2, 3 and 4. Fine. So simply the wind force in Z direction is also applied. Let's have a look. Yeah. Now we can generate the combination. Let's generate the loading combination. Automatic load combination as per AISC. Generate loads, add, close. Then we have to add perform analysis command. And then we have to go to design phase. Steel design, let us select a allowable stress design method. Let us check. Let's select the units kpinch so that we can check that the value of Fy .36. Okay, fine. Let's for the time being put everything on default and say check code add, check code assign to view. Right. So let's save. Let's analyze. No error, nothing. Done. Okay, fine. So here the values are very small. It's not significant. Select all specification, failed member. So bracing have failed. We can modify the bracing. W 8 by 40. So let us select T section instead of 8. Let us select W 12 by 79. Okay, close, save. Let us run once more. done. Select all failed beam. Still these beams are overstressed. Oh, let us edit. Instead of W12, W14 by 90. Okay, sorry, no. Okay, so let's save. Once more revise. I can use the select command, but I just wanted to do it manually. Okay, no problem. So here select all failed beams. Couple of beams are failing. One more try. T section 14 by 90, so I should select 14 by say 120. Okay, hopefully this should work. Oh, still overstressing of 0.03. Okay, I don't want to see any overstressing. 14 by 120, so let me select 14 by little bit 145, little bit higher, let's say 14 by 193. Okay, so select. Oh, still. Oh, sorry. These are tension members only, so we should not check L over R. Okay, this is my mistake. We should go to design, parameter, so let's add one more command. Do not check for cylinderness. Let us select okay, we can do one thing. We can select menu manually. and then we can select these also. And let us edit our file. We can now select even a very lighter section. That was my mistake. We can fine tune this model, no problem. Select by specification, failed view, nothing. Yeah, I know. So general, we can reduce that one. Edit, W T by 120 should be more than enough. Yeah, we can reduce optimize, no problem. We can do it. Let's save, analyze. Select by specs, all failed beams, nothing. So that means can qualify, although it can be optimized, but this is a tutorial only. So just to demonstrate that this is the way we design the structure. There are other parameters which we can define, rather we should specify, for example, the releases or the tension only command we can use for the bracing especially. We can define the releases, or we can define them as truss. Yes, that can be done. Like for example, if we select our all these members, then they can be defined as member specification. They are truss. Okay, yes. Let us save. Specs, member truss, yeah, no problem. Let us run once more. No error. We can select. Still we are safe. The ratio will of course be very small, we know. So this is the way steel shed is designed. In next video I will design the connections, and I will design the base plate, I will design the foundation, etc. So for the time being, this is enough. Thank you very much. Bye.